arithmetic sequences. So there's your title. Anyway, an arithmetic sequence is a certain type of sequence. Formally, an arithmetic sequence is a sequence in which each term differs from the preceding term by a constant amount. This amount is the common difference. So an arithmetic sequence has a common difference. I don't know if that's how you're supposed to split that word, but we're going to go with it. Common difference. We generally use D for that. So for example, if I had the sequence 142, 146, 150, 154, etc., the common difference would be 4. Each term is 4 apart. You're adding 4 every time. -5, -2, 1, 4, 7, etc. The common difference would be 3. Then if I had 8, 3, -2, -7, -12, the common difference there would be, geez, get your equal sign with it, Mom. Common difference would be -5. Now, if you were to plot a graph of this kind of sequence, basically, it would look like, it'd still be a discrete graph and that you'd have just individual dots, but basically they'd all lie in a line, like so, the slope of which would be the common difference. So it stands to reason that it would be fairly easy to come up with a recursive formula for one of these things. If I want to get a term, I can take the previous term and add to it the common difference. Well, that makes sense. So I want to write the first 6 terms of the following sequence. A1 is 6, and AN equals AN minus 1 minus 2 for n greater than or equal to 2. Well, if you notice, the first term is already given. Right here. And also, if you notice, this thing right here would be the common difference. So, there's your first term. So A2 would be A1 minus 2 based on this definition right here. So that would be 4. And then the next term I would take 4 minus 2, which would be 2. And the next term I would take 2 minus 2, which would be 0. And the next term I would take 0 minus 2, which would be -2. And the next term I would take -2 minus 2, which would be -4. Now, while that's easy to come up with, if I want to know what A6 is without doing the other 5 before it, this doesn't really work well. So what we need to do is we need to come up with an explicit formula. So, notice Well, that's nothing genius right there, but A3 is A2 plus D, which would be A1 plus D plus D, right? And A4 would be A1 plus D plus D plus D. So if I continue that pattern, the nth term of an arithmetic sequence would be A1 plus n minus 1 times D. And that's our explicit formula right there. So one thing we can do with this, find the 8th term of an arithmetic sequence with first term 4 and common difference -7. Well, I know that an is equal to a1 plus n minus 1 times d. Well, in this case, n is 8. So a8 is equal to 4 plus 7, because 8 minus 1 would be 7, times -7, which would be -45. Now, at some point, it might be useful to take all the terms of a finite arithmetic sequence and add them together. Like, for instance, if I've got chairs in an auditorium and each row has 2 more chairs than the row previous, it might be useful to add up how many total chairs I have in the auditorium. So anyway, let's examine this. The sum of the first n terms in an arithmetic sequence. And this is sometimes known as the nth partial sum. Partial because you're not adding all the terms together, you're just adding a finite number. So we'll abbreviate that with S sub n. So Sn equals A1 plus A2 plus A3 plus ... plus An. Now, it would be useful if I could come up with a formula for this. And we can. So, consider this. I have Sn. Another way I could write it would be A1 plus A1 plus D plus A1 plus 2D, because that would be A2 and A3, plus A1 plus 3D, plus ... plus all the way up to An, right? Now, another way I could look at this is I could run this sum backwards. I could start with An, and then I could do An minus D, An minus 2D, because I'm starting at the end. So if I start at the beginning and add the common difference, or I start at the end and subtract the common difference, I get the same thing. So this would be plus An minus 3D plus ... all the way down to the end, which would just be A1. Now what I'd like to do is I'd like to take these and add them together. So I get 2 times the partial sum is equal to, now notice, this is going to be a1 plus an. These two terms, the d's cancel, and I get a1 plus an again. The d's cancel, and I get a1 plus an, all the way to the end. Now there are n terms, so I get n copies of that. So that means that 2 times s sub n is equal to n times a1 plus an. So if I divide by 2, I get that s sub n equals n times a1 plus an divided by 2. And that's the formula for the nth partial sum of an arithmetic sequence. So this would be the sum from I equals 1 to n of a sub I. All right. Find the sum of the first 100 terms. So I want to find S100 of 1, 3, 5, 7, etc. So I know my formula for S100 would be 100 times A1 plus A100 divided by 2. Well, first of all, I could divide the 100 by 2 and get 50. Because these are multiplied, I only have to divide one of them. And then A1 would be 1. But then I need to know what A100 is. Well, I can use my explicit formula. A100 equals A1 plus 99 times D, because it would be 100 minus 1 from earlier. Well, D is the common difference. Each one of these is 2 apart. So this A100 would be 1 plus 99 times 2, which would be 199. So I would have 50 times 200, which would of course be 10,000. Okay, last one before we go. I'd like to find the sum from I equals 1 to 25 of 5i minus 9. Well, first of all, we need to verify that this would be arithmetic. So note that the first term would be 5 times 1 minus 9, which would be negative 4. The next term would be 5 times 2 minus 9, which would be 1. Then 5 times 3 minus 9, which would be 6. So notice that each one of these is 5 apart, so the common difference is 5. The first term is negative 4. And the 25th term, which would be the last term, would be 5 times 25 minus 9, which would be 116. So to find this sum, the sum from I equals 1 to 25 of 5i minus 9 is equal to 25 times negative 4 plus 116 divided by 2, which comes out to be 1,400. And that's it. Bye-bye.